Hi, I'm Al. You can call me Al. Let's take a brief look at X-rays and ionization. Remember, the GXMO is a basic test. In-depth knowledge of radiography is not necessary, but a good basic foundation is. So, here is your basic foundation. Atoms are known as the building blocks of matter and are composed of a nucleus containing protons and neutrons, and electrons which are orbiting the nucleus. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. Remember, opposite charges attract. The positive force of the protons pulls in the negatively charged electrons. This binding energy keeps matter cohesive. The number of protons determine the chemical element and represents the atomic number. Mash the periodic table button at the bottom of the page and you will see what I mean. The atomic mass number is the number of protons plus the number of neutrons and is always a whole number. On the other hand, atomic mass is a measurement and rarely is a whole number. An isotope is an atom with the same atomic number but a different atomic mass number. An isobar has the same mass number but a different atomic number. An isomer has the same atomic number and the same mass number. Finally, an isotone has the same number of neutrons and different number of protons. Are you cool with this? Great, moving on. A photon is the smallest quantity of radiation, with an X-ray photon being a quantum of electromagnetic energy. A photon moves at the speed of light or 186,000 miles a second. This is so fast, you do not feel it slicing through your tissue during an X-ray. Photons have no mass but they do have electric and magnetic fields. In the electromagnetic spectrum, X-rays are separated from visible light by the ultraviolet. X-rays are grouped with gamma rays, with gamma occurring inside of the nucleus while X-rays occur outside of the nucleus with the ejection of an orbital electron. The number of protons will equal the number of electrons in a stable atom. If there are more electrons than protons, we have a negative ion. If there are fewer electrons than protons, the ion is positively charged. X-rays are classified as ionizing radiation. Non-ionizing radiation includes microwaves, radio frequency, ultraviolet and visible lights as well as infrared. X-rays interact with matter in a couple of ways. They can be totally absorbed by the matter they pass through. This is called, are you ready for it, absorption, or more precisely, differential absorption. They can pass through matter, but exit the matter at a decreased speed or in a changed direction. This is scatter radiation, known as Compton's scatter or the photoelectric effect. Finally, X-rays can pass through matter unaltered and this is called transmission. As we know, X-rays are ionizing radiation. An electron is boiled off of the filament in the cathode. Electrons are negative, the Debbie Downers of subatomic particles. But just like anyone who feels so bad, they want to feel better, so they are attracted to the positive, more upbeat anode. Those projectile electrons smash into the target atoms like a bad date, and interact with the target atom's orbital electrons. These interactions do not stop at the target. They continue as the X-ray beam enters the patient. These interacting X-rays are the patient dose. The X-rays disturb and continue to pull in electrons from atoms they come in contact with. As the X-rays exit the patient, the interaction continues to the IR and the film creating the X-ray image. Well, that's all I got for now. I am sure I'll be back. Just remember, it's like I always say, everything is relative.